All right. Hello, everyone. This is your bald host, Mert, speaking on behalf of Jack today. I will be doing a solo episode with Yannik from Arcium, who has a lot of cool stuff in the works. And this will probably go out by next week or something. So I'm sure there'll be more news by then. But we got some exciting stuff to talk about. So Yannik, thanks for coming on the show. How you doing?
Thanks for having me. Doing great. Currently in New York during DAS. Speaking with a lot of, I guess, more traditional folks who seem to care a lot about privacy.
So people do care about privacy. That is good news. Let's maybe start from first principles here, or not first principles, but the history of you and what your team has done on Solana. I believe most people would be familiar, at least on Solana, with the first iteration, which was called Elusive. So why don't you talk a little about, first of all, how you got onto Solana? Was it Anatoly? Was it Super Team? Was it something else? How did that happen?
Yeah, so we started with Elusive roughly 3 years ago. And I got into Solana due to building Elusive, right? And so our team of 4 co-founders, I actually was the last one to be onboarded into Solana, I think. The other 3 have been in Solana since 21. And at that time, we were this technical team that wanted to build something with new forms of cryptography. And we were quite into privacy. And I can't really describe it because a lot of people ask me that, why did you pick Solana? Why didn't you build it on Ethereum? But it just intrinsically made sense to do it on Solana because at that point it was this fast network. We've seen this this amazing ecosystem, and at that point we went to the hacker houses. And so I think the first hacker house that I went to was the Prague hacker house, where I met one of my co-founders, and then the 4 of us went to the Miami hacker house in the beginning of 22. And in Miami, I met Toly and Austin and had great conversations with them. And Toly, right from the get-go, supported us. And I think, I don't know if it was directly in Miami, but he was our first investor, right? We haven't even talked with any VCs, but Toly joined us in order to support us. So that felt amazing. And we were instantly aligned with this ecosystem since we really saw this big support from the ecosystem. And I think that was even before all of Super Team even started. And so right from that point on, we started building Elusive. And what we were doing with Elusive was we were building transactional privacy, so that the most basic form of system transfers or SPL token transfers were private using zero knowledge proofs. And through building out this tech, we sort of realized that it wasn't powerful enough, because when we were doing like private swapping, that sort of wasn't this super cool solution, but instead relied on a lot of zero knowledge proofs and had slippage, and required an enormous amount of on-chain storage, and was relatively slow because the user had to locally generate some zero knowledge proof. And we were building out this decentralized compliance system, which should be able to, using confidential computing, enforce some decentralized compliance rules. And so through the process of actually building out this system using MPC to allow for blind encrypted computations to take place over encrypted state, we realized the potential of using that technology in general to be offering bigger privacy applications. And so that's why we then evolved into Arcium, because we wanted this technology, which we now call Privacy 2.0, to be used for privacy instead of just Privacy 1.0.
Cool. Okay, so first part of that answer seems to be basically, well, we picked Solana because of the vibes-based development. I do want to talk about a whole lot of stuff about Privacy 2.0. I do want to maybe touch on quickly, because when you guys started doing, let's say, private swaps or transactional privacy, Solana was, let's say, a bit underdeveloped, and probably even ZK proofs and privacy overall was a little underdeveloped. And so you face a lot of issues. Since then, there's been some changes, different types of syscalls, maybe different ways of development on Solana, maybe ZK itself, especially with folks like Risk Zero, for example, or Anagram with Bonsol, have made some headway in building out some primitives. Do you think it would still be the same challenges today for building transactional privacy? Like, how has that evolved, if at all?
So building out this very basic form of transactional privacy has definitely become way easier. So there's core primitives now. You mentioned Risk Zero and Bonsol, where you can do a lot of CK proving, where the developer doesn't even have to be able to write arithmetic zero knowledge proof circuits. I think that has advanced quite a lot. Also, we have, that might not be activated on mainnet, I guess, but at least in token 22, we have confidential transfers, right, as a native token extension feature. So that's something that is there. So it has become way easier. And the core idea behind Arcium basically is to make those things even more easy, to allow for even more powerful applications in that regard and make it even way easier. Because the way that we think about it is that the developer should, within their program, just be able to specify this should be private, this should be public, this should be encrypted, this should be visible to this party with that public key, and that's it. And so we are really trying to push to reach that point where you don't even have to think about anything cryptographic like proving things, but instead it's just you specifying what should be public, what should be private.
So what I want to do next is, you guys rebranded into Arcium, and you can talk about maybe what went into that. But the concept of Privacy 2.0, which we'll get into, which seems like it's basically something like Privacy 1.0 was maybe a little political in nature, or just was very basic, and Privacy 2.0 is more like, well, actually, if you have encrypted shared private state, then you can enable things that weren't even possible before, which is a cool concept. But I would say it's a little abstract. So what I want to do is, I want you to be very clear. I want you to talk to two different types of people. One is the degen retail user, or somebody who just transfers stuff. They use their Chrome extension and they just want to do things. So a very basic kind of type of user. And then I want you to think of a developer who might be interested in building things on top of this. And I want you to explain exactly what the new Arcium enables, what it does, and why they should care.
Yes. Okay. So there's, if we look at the degen trader using the Chrome extension wallet, what Arcium enables is that, for example, you get access to things like dark pools. So you're able to trade in full privacy directly on Solana, which is something that previously hasn't been possible. So if we look at the stock market, nowadays 60% of daily US spot volume happens in dark pools of exchange. And that's something that's only accessible to the largest kinds of institutional whales. And so you'll be able to do that as well, to be able to trade in a fully private way and move your assets. You're able to keep your assets private. You don't have to be afraid of, doxing your wallet address and then getting robbed in some city you went to because you have some large asset holding. So I think those are some of the aspects where this kind of financial privacy comes into play. And why privacy 2.0 for this? Well, things like dark pools require so-called encrypted shared state. So if we want to build an encrypted order book, I need to be able to place orders, but you also need to be able to place orders, and every single other user also needs to be able to place orders. And everyone has to be able to do so in a encrypted way, right? So every single one of us just has an order, they encrypt it, and we upload it on chain. And so then the problem is, how can those orders be matched when nobody can see them? And that's where Arcium comes into play, because Arcium is then able to match all of those orders, which only exist in an encrypted way, without Arcium seeing them. And that's incredibly powerful, because dark pools are only the most naive implementation, I guess, of encrypted shared state. There's way more that gets enabled through that. And I guess we can touch on that more in a second as well. But what I find interesting is, since we acquired our largest Web2 competitor last year, is that we can also offer things where, instead of submitting encrypted transactions, what everyone is doing is they're explicitly uploading encrypted data, let's say encrypted healthcare data, and then using Arcium to train a machine learning model on top of all of this data, without anyone ever having to share a single bit of information about the underlying data. And at the end, everyone can get the model back, or even this model that is being trained can remain in a fully encrypted way. And then you have a program on Solana which functions as a, I guess, gatekeeping mechanism, where you have to pay a fee in order to use the model, because you can't see the model is encrypted. And you again submit some sensitive encrypted data to run predictions using that model, and you get an encrypted output back. Nobody else sees anything, yet there can be some economical incentive mechanism to, in the first place, provide the data to train those models. So that's, I think, one of the craziest concepts ever. If you think about being able to train these kinds of models over sensitive data. And so everything in between, from having fully private trading up towards end-to-end encrypted AI, gets enabled, because we can operate with Arcium over encrypted shared state, where every single one of us has some data that is being encrypted. Nobody else can see it, yet we are able to process on top of all of this data as if there was someone who could see the data and process it. And the secret sauce behind that is, in our case, using secure multi-party computation with semi-homomorphic encryption, which enables that, which is what's cryptographically running within Arcium. And the outputs then, after those secure multi-party computations have taken place, are being settled back directly to Solana. And for us, it really was building with this tech, and back in the day, using the tech and thinking about, okay, how can we use encrypted computing to offer some compliance system where we can have some minimum trust assumptions, while at the same time being able to keep illicit players out of Elusive. That's basically how we were designing this. And then we realized, okay, it now becomes way more powerful to actually build cool privacy applications using this tech, where the developer doesn't have to rely on those way more primitive kinds of applications.
So you gave the example of the dark pool order book, let's say. So, okay, let's walk through this. You have your bids, you have your asks, you have your cancels, all this, but they're encrypted, and so nobody can see what's happening, which, by the way, might be interesting for MEV mitigation, but we can talk about that later. Okay, but then Arcium has to do the matching here, right? So how does that work? How can I match encrypted shit?
That's a billion-dollar question, I guess. Let's first explain the concept in an extremely simple way. So you have some secret number, let's say your total wealth. I have my total wealth, and a third party also has their total wealth. Let's say Toli, right? So the three of us all have our wealth, and we want to compute the average of our wealth without sharing the actual wealth each and single one of us has, which with three parties is sufficient enough, actually. And so how can we do that? Well, we start off by you generating three random numbers, me generating three random numbers, and Toli generating three random numbers. And each single one of us generates those three random numbers in a way where if we were to add those three random numbers together, that would equal our individual wealth, right? But if you only have two of those numbers, it's random. Only if you have access to all of those numbers, you're able to compute the secret, which is the wealth. And so after everyone has created those three random numbers, we distribute them. So I send you one random number, I send Toli one random number, you send me one of your random numbers, and Toli one of your random numbers, and Toli does the same thing. And so after this process, every one of us ends up with three random numbers, one from my secret, one from your secret, one from Toli's secret. And I don't learn anything from that because it's just a random number, right? And so I only have this batch of random numbers. Now, what can I do with that? I can now locally add those three random numbers together. Don't learn anything from that. But now I have, again, introduced randomness because I've been adding those random numbers together and I've computed the sum. And so every one of us does that. And now in the next step, I just publicly announce the sum that I've computed. You do the same thing. Toli does the same thing. Everyone has access to those sums. We don't know anything about them. And so what we do now is we just add those three sums together and at the end divide by 3. And voila, we now know the average wealth. And it's actually almost that simple how secure multi-party computation works. You have secrets and you create so-called secret shares, which are random numbers based on how many people are part of the computation. Those get distributed, everybody runs computations, and at the end, everything comes back together. And that's the process of secure multi-party computation. And what we've done with Arcium is we've extended that so that, let's say, we're building an order book. By default, if you were to use this kind of MPC, every single trader would have to be part of the computation, which is insane. So instead, we say it should be possible for a network to run the computation. So instead of someone placing an order, generating those random numbers, they just encrypt data and send it to the network. And then every participant in the network, using a private key they have or a key share, they can transform from the encrypted data into a secret share. And so everybody can do that. And then they can run this computation. And so with this kind of encrypted computation, we are now able to, within this computation, represent the matching of two orders without anyone seeing the orders. And that's basically possible because we can represent any computation as a set of additions and multiplications. And by being able to represent any computation as the sequence of additions and multiplications, we can just encrypt the data, turn it into random numbers, and everybody does those things. They exchange stuff, and at the end, combine everything back together. And what we did for that is we've built a custom Rust compiler so that the developer doesn't have to think about additions and multiplications and how all of these things play cryptographically, but you just write a normal computer program. And in the case of Solana, you just write a normal Rust program, and then you specify, this function should be private. So the compiler knows that, and then it can turn it into a secret, into a sequence of additions and multiplications, and the Arcium network can process that. But the secret really is that you can operate over encrypted data this way.
So basically, you have this primitive, let's say, well, the one you described, and in the example of calculating average wealth between, three parties, or but really n parties, is such that they basically do all these things between them, randomized, but then you can kind of get the final result is it's not really traceable back to any single person, but it must be accurate due to the property of these numbers. I won't get too boring with that stuff, but yeah, that's very mathy. That's fun. Well, okay, but so we're on Solana, which means we care about latency. That feels to me like if you're matching orders, we'll probably add some latency, right? For sure we'll add some latency. How do you think about that? Like, what is the extra overhead?
So I think that's one of the most important aspects about privacy in general, because what really is the privacy 1.0 thing of going about it is even worse than just introducing latency. It's really, hey, traders and developers, do you want to come to my blockchain network? Because my blockchain network comes with privacy. That's my mode. I think that's one of the really bad issues that we've seen in the past. I think privacy has to be at the fingertips of Solana users and developers, right? And for that to be actually usable, it has to be good developer and user experience, and at the same time it has to be fast. And so there's different kinds of technologies. Secure multi-party computation is so nice, because if we compare it to other similar technologies like fully homomorphic encryption, this kind of MPC that we've developed is multiple orders of magnitude faster. And that's because, that might be too mathematical to go into, but so-called pre-processing, which is something that those nodes can do, running some computations in order to generate some so-called correlated randomness, which then during the computation can be consumed, which speeds things up incredibly.
Like a cache.
Yeah, basically like this. Basically generating some cache of random secrets that are actually correlated. So what using that allows for is to skip multiplications. To an extent, you don't actually have to perform a multiplication, because in the past they have performed a multiplication, and then based on performing a multiplication, they can scale that. So they generate random numbers, multiply them, so it's correlated, because they also have the product, but nobody knows those three, and then they are able to use them in the actual computation, and that speeds things up drastically. And when building encrypted order books, one important aspect is also how many orders can be placed in that order book, and how efficiently can I operate over those orders. And I guess one of the key issues with how those cryptographic operations function is that if we have a zero knowledge proof, FHE, or naive MPC, you would always have to put this order book into the computation as this encrypted data structure, table, array, whatever, right? And if you have such a data structure, which is encrypted, and then you say, I want to access element number X, and X is encrypted, that becomes expensive, because now you need to represent your index in so-called one-hot encoding, and then multiply every single element in this array, multiplex it, and then add all of them together. And yeah, that isn't scalable at all. And so with MPC, we're actually able to make use of so-called oblivious data structures, which sit outside of the computation, and then can be accessed in a way where you don't see what element has been accessed. And that allows for way bigger computations to take place. And so, I think that's why we actually decided to go with MPC, because we wanted latency and latency efficiency, and don't want the latency of other cryptographic protocols. Still, it introduces latency. That's clear, But right now, what actually is the biggest latency that we are looking at for the current architecture has been the Solana transactions.
Okay. So help me understand the overall architecture end to end, perhaps. So assume that somebody has built this dark pool where I go and make a trade on Solana or on Arcium. Where does the transaction start from? Is it a regular Solana RPC and then it goes directly to this MPC network and then gets directly settled to Solana later? Like, how does that work? How does Solana use, basically?
Yes. So the most simple form of using Arcium is that you call Arcium through CPI. And so you have your program, let's say your dark pool program, that has some functions specified within your...
And it's deployed on Solana. So it's a smart contract on Solana.
Yeah. So smart contract on Solana. And so you have your smart contract, your program on Solana. And within that, you have specified, okay, I want this function to be private and this state that sits in this account is encrypted and will be processed by this function. And so what you do then as a developer is within your Solana smart contract, you specify at what point in time you want this private function to be executed, right? You call it. And then you specify what should happen after it's executed. So you specify a callback for that function. And then once the function is being called, what happens is when you're doing it through this CPI, you call it calls Arcium smart contract and inserts the computation basically in an on-chain mempool. And simultaneously, that gets picked up by the Arcium network. The Arcium network processes it and settles it back. And then via callback, calls whatever you specified as the instructions that should be executed after the computation has been finished. And so for the developer, it really looks like this is the call of the function, and I simply specify what should happen afterwards, and then it's being taken care of by Arcium. And so that's this fully on-chain flow of Arcium picking it up through the on-chain mempool and then settling back. We also have a flow where it's basically you sending something directly to the Arcium network, and then it's settling back a computation on top of Solana. So there's always a computation on Solana involved, be it for a bulk of computations that are being executed within Arcium or a single computation. And you can trigger those computations directly from on-chain, but also from directly communicating with the corresponding cluster within Arcium.
To summarize, there's two ways to do it. One is you directly call the Arcium network, which let's say is, well, maybe let's actually talk about that. When you say the Arcium network, what exactly is this? Obviously, you have some nodes, you have a token and all these things, but what exactly is the network?
The Arcium network is the first L2, L3, and L4 combined. So no. I mean, Arcium itself is a stateless computing network, and so that has been very important to us to be able to just build out Arcium as this computing processor, if you will, that on Solana serves as a network extension. So you don't have to, let's say, bridge state into Arcium and then you can settle it back on top of Solana. But instead, it's really Arcium is just processing things that you tell it to process. And so Arcium is a set of nodes. Anyone can run a node within Arcium, and those nodes get partitioned into computation clusters, and those computation clusters are so-called dishonest majority clusters. So the trust assumption for every single cluster for privacy is always one single honest participant is required in those clusters, but you can specify clusters however you want. So you can build a cluster of 200 nodes, or you can build a cluster of 2 nodes. And the user at the end of the day, so the developer specifies what cluster should process their computations. And yeah, that's basically how the network itself is set up. The network itself is set up by having again a smart contract, a program on top of Solana, which serves as this coordination layer, if you will. So we use Solana as a coordination layer in that regard. And in other regards, it also serves as a state layer, where you either have direct on-chain state that is public or encrypted, or you have just references to on-chain state, where you then can pass off-chain state. And so there's this coordination program, and so a node can just join there and what we call unlock their hardware, because there can be nodes with different hardware capabilities. So there's not some strict requirement of you need to be able to process this many computations in a given amount of time. You basically rather run some benchmarking that then produces the number of compute you can process. And based on that, you might be chosen as a node to be part of a cluster, right? Or you might not. Always you will be able to join, maybe open up some permissioned cluster. And I think there will be also more over time, I guess, a higher level of specialization between the nodes within Arcium. Because in Arcium, we have 2 cryptographic protocols as well. One that is really fine-tuned for those on-chain applications, but also one that is really fine-tuned more for the AI applications. And so for the AI applications, it definitely would make more sense to have some hardware that is really fine-tuned for a CUDA implementation. And so nodes can specialize in what kind of clusters they want to be part of, what kind of computations they want to execute. And yeah, that's the overall structure of the network.
Okay. So I want to drive all this home with one concrete end-to-end example. So let's assume that I have 10,000 USDC. Okay. On-chain on Solana, just from shitcoining.
Goddamn, you're rich.
I'm quite well off with my 10,000. And okay, and then so I let's say there's a new app called Yannik.x or some shit, and it's a smart contract on Solana, and it does these CPIs and stuff and uses Solana as a coordination layer to some extent. It takes a state from Solana, which is a 10,000 USDC. It then puts it into let's say your smart contract, and then I'm guessing I now interact with the app through the other smart contract, or let's say the Arcium network. So a bunch of shit happens on that network. And let's say I'm a horrible trader, so now I have $5 left. How does that, because one thing I'm confused about is where does that, because it has to come back to Solana at some point. How do I know that it's private on my end in the ultimate state, like when I actually have to get off?
Yes. So let's say there's this application, and so you enter into the application like you enter into Drift, I guess, right? So you open an account in the application, you place your 10,000 USDC there. You then do some encrypted ominous action, I guess, and at the end up with 5 USDC. And so the way it would be implemented using Arcium is that once you enter this application, your holding gets encrypted. And after the fact, after you've performed any kind of action, or let's say you've performed some order book trade, right? How do you know what your remaining state is? Because everything is encrypted. And so the cool thing about Arcium is that in those encrypted computations, you can specify that this is the public key of Mert who performed the trade. So please give him access to the information about what the output is. And so you explicitly are the only one who can see what has happened, or what the result of your trade is. Nobody else can see it. So you can have this kind of access control where you say, okay, for one, we have the encrypted state, and then we also have, let's say, encrypted message that is being passed to Mert, or that is being passed to some other party as well, which can be interesting if you're, as a developer, thinking about compliance and whatever, right? So you can just specify, this is a public key, do something with that public key. And yeah, then you have knowledge. You're the only one who has knowledge about you having 5 USDC left. And at that point, you could decide to then exit this application, right? And at that point, you would move publicly 5 USDC to some wallet again.
I see. I guess the part that I'm on here is, well, after I enter Arcium, and let's say I don't want to exit because I don't want people to, because like once I exit, let's say certain things will be visible, maybe not everything, like it'll still be, there's uncertainty involved, but I probably want to use that directly with other things. Like let's say I want to pay for something. And so, which means that it would have to then connect whatever this payment processor is, it would have to connect directly with Arcium. Is that right?
So I think this concept even of thinking about entering into Arcium is sort of misled, right? Because Arcium really serves as this compute layer. You're not able to move any asset to Arcium. You're basically,
so all state is on Solana.
Yes. Yeah, 100%. All state is on Solana. So Arcium is just this processor that can process encrypted stuff, right? And so you have everything remaining on Solana. I think that's important. I think otherwise Arcium would be an L2, I think, right? And so in this case, Arcium really serves as this network extension that gives your programs more power. But you don't move anything onto Arcium. Also, something important that we've added into our architecture is then censorship resistance, because those dishonest majority MPC protocols, which basically means any single one participant within Arcium has to behave honestly, right? Are ideal from a trust perspective because anyone can also become an honest actor, bring the trust assumption down to 0. At the same time, they have been very impractical because they come with a high DDoS risk, because one dishonest actor could just DDoS computations. And that's something that you definitely don't want for your dark pool, let's say, when then some node can decide, okay, because of this game theoretical strategy, I can do this or that. And so we came up with a censorship resistance protocol that allows to cryptographically pinpoint any misbehaving node, and then we can punish them. And so that's quite nice, because then it's really just we allow Arcium to execute the computation, but it's never I'm moving stuff there. It's really just it's processing it.
So we've talked a lot about the dark pool application as an example for reference, and you have this, let's say, way of telling the story, which is, well, there's privacy 1.0, which you go to your own blockchain, something like Monero or Zcash, and that's kind of been privacy before. And then now it's actually, well, you can use shared state to encrypt the shared state to enable things that just weren't possible before. And so we talk about the dark pool. What are some other use cases that you think might be useful from this?
So I think in general, what privacy serves is, and that's also something that privacy 1.0 really has mainly focused on, which is this political avenue, which is an important avenue, right? Saying that privacy is something that we need on top of the blockchain, because otherwise it will not be a superior financial system even. So I think that's an important aspect, but it shouldn't be the sole focus. I think for applications and teams, it's way more important to be enabling more powerful features. And encrypted shared state really serves as this powerful primitive with which you can do a lot of things. I think it's also quite narrow to only think about privacy in the financial sense. Because what we've seen on Solana is a lot of consumer apps people as well requiring some level of privacy. And that can start with something like building a DocuSign on top of Solana, where you maybe wouldn't want all of your contracts to be public, while at the same time not wanting to rely on some centralized servers to be storing all of those documents, right? And so with Arcium, you can encrypt those documents and then give third-party access. So you can just say, okay, this wallet's public key identifies this user, and so I give them access to page number 2 and 3 and redact the names of some individuals, whatever, and then they can have access to this verifiable, encrypted, only visible to them document, can sign it. Everything is coordinated through the blockchain, is verifiable. So I think like I think we need to think like that, and we'll see way more applications on the blockchain because there's just this powerful privacy primitive. And not everything has to be private, but everything can be private. And you can still compute on top of that. So I think that's one of the examples. And also another example is actually making logical decentralized AI stuff. So actually being able to build things that make a lot of sense. And we've funnily enough, and most likely we're actually going to be announcing that next week. So maybe it's going to be announced at that point. I'm not fully sure, but we've been pursuing some big Web2 decentralized AI use case where they're leveraging Arcium on top of Solana to be training AI models of a highly sensitive data. And that's very far separated from what you were able to do with this Monero and Zcash like infrastructure, right? Now you're able to bring entire Web2 institutions on chain because they want to leverage encrypted training over distributed sensitive data. And blockchain in that case can even serve as this ideal coordination layer. So I think that's what Privacy 2.0 is about. In any aspect, more powerful applications.
Okay, some alpha there with some encrypted messaging, basically as to the release date and who and what, but we'll get there. The other thing I want to ask, which I'm going to guess most people are probably listening for this reason, so I don't know why I left it until the end, but so you guys announced a CoinList sale, which is to say you're going to have a token. How does the token work? Why is it useful for the network? How should people think about it?
Yeah, so as I said, Arcium is this this permissionless network where anyone can run a node, similar to Solana. And the CoinList sale is actually going to be starting on the 24th, which, funnily enough, is 5 years after the Solana CoinList sale has ended. So Arcium is this permissionless public network that anyone can run a node in, and you unlock your hardware claim within Arcium by staking that token. And so, depending on how much compute you can offer, how much compute you want to offer, how high the dependence of the network on you actually then coming through and providing that compute is, you need to stake more. You need to unlock that potential, because on the flip side, if you misbehave, if you go offline, or if you try to cheat in computations by sharing invalid data and hence causing them to fail, you'll get slashed for that. And so we have this native staking and stake delegation system, also with a sublinear curve that gets applied for stake delegations. So it incentivizes distributed staking to multiple participants, because at the core of Arcium, it's very important to actually have distributed nodes. So that's one aspect. And then the concrete way of paying for computations is actually something that doesn't happen within the Arcium token, but instead it happens using Sol, because that's, again, way better developer and user experience. When you want to place some encrypted order in some order book being built on top of Arcium, I think it would be quite bad if you had to have both Sol to pay your gas fee and then some Arcium token, and otherwise you couldn't place the transaction, right? And so you just have to pay in the native token, and the connection with the Arcium token then happens under the hood with that. And so that's more or less the core functionality, I guess, of what Arcium, the Arcium token serves right now. And then the Arcium token basically is functioning with a dynamic supply and demand mechanism for the actual computing power. And so the network itself wants, and we have some demand threshold curve there, which can be adapted through governance, I guess. Once there is enough demand, priority fees apply, which then will be used to burn the token. And so there's this native burning and buyback mechanism baked into the system.
So 2 more questions for me. One is going to be maybe a bit more philosophical. So privacy has been around for, the entire concept has been around for a very long time. Of course, the whole, let's say, raison d'etre of crypto is kind of the cypherpunk movement, and encrypting things is basically why this thing started. However, it seems like crypto has maybe, I don't want to say lost its way, but maybe privacy hasn't been really the focus. And I kind of talk about this. You can have economic freedom, you can have performance, you can have things at scale that finally work. But I wonder if without privacy, it's all kind of on some weird house of cards. And so what do you think we need to kind of change that? Like, how do you think privacy in crypto unravels in the next 5 years?
I think I would definitely agree that it's a house of cards if we don't think about privacy and implement it and make use of it. I think at the end of the day, we could wake up in a situation, speaking from a philosophical and cypherpunk level, that we wake up and then we realize that we now live in sort of the European Union. We just overnight wake up and realize that, because I've seen yesterday that Christine Lagarde now wants to implement the digital euro this year, and transfers starting at 300 euros will be surveilled, right? And so on top of this public ledger, transfers starting at $0 US dollars will actually be surveilled, right? And so I think that's something that we don't want. I think we shouldn't be willing to give up this this right to privacy, and we don't have to, because using these ledgers we can have privacy. I think that the answer is have something like Solana, have this transparent public blockchain, and then within and on top of that blockchain have privacy where privacy should be, right? Because then you have it baked in, but you don't force everything to be private, because there's value to being able to also have public, transparent state. And one of the concerns that, funnily enough, a lot of people raise about privacy is also that now it introduces a lack of transparency, which is actually which has been true, I think, for privacy 1.0. But for privacy 2.0, you can add more accountability and transparency, because you can't just have any type of encrypted state, and then you can run a computation over that encrypted state. And that computation can enforce some accountability measures while maintaining privacy for everyone. So I think we can now be way more creative in the way that we think about what privacy actually enables. And so I think the correct framing as well is that privacy enables security and more powerful applications. And I think if we just go down the route of being the, I guess, preacher standing on New York Times Square and then saying, hey, we need to have privacy, otherwise the world's going to end, I think that will not lead to this outcome. I think what will lead to the outcome is making privacy a logical business decision to be using privacy. And I find what's interesting is that in the recent US election, even J.D. Vance spoke about privacy in this way, and that has been the first time, as far as I know, that I've ever seen a politician speak about pro-privacy, because for one, it's a human right, but also it will allow hackers into our systems, right? When we have backdoors everywhere. And so that's the way I think about it. Privacy should be this powerful tool that anyone will use, because it makes applications more powerful and secure. And through that, we will then have privacy for everyone.
I do want to end on a left curve note and put you on the spot here. You don't have to give me a justification. Monero or Zcash?
Definitely Zcash. So I don't know if you've seen the news about Monero's ring signatures. I can send that to you after, but Zcash all the way. Suko is the best.
All right. Well, Mr. CEO of Privacy, thank you. Appreciate you coming on. Appreciate your time. Best of luck. And please follow him on Twitter to keep up to date with unstoppable private encrypted computations. Thank you for listening.